Hello, and welcome to Model-Driven DevOps with NSO. So, hot out the gate, we're going to go ahead and unpack this title, starting with DevOps. So I click on this. Okay, so DevOps for networking. Well, how does that work? Well, traditionally, you'll see two sections in networking shops. You'll find the network engineering and the network operations. And what we're going to do is merge those two shops together into NJOPs, as you will. So if you think of engineering and operations together, of course, we're going to need new processes, right? Because they're going to operate as one. There's going to be requirements, there's going to be configurations defined and changes to the network. And if there's an issue on the network, then there's going to have to be some kind of ticketing system, the same one that the engineers use, because they're all the same now. And then the DevOps engineers are going to go ahead and fix that, right? So you have to have new operating procedures. And the way we're going to make that work is we're going to treat our entire infrastructure as code. So how we used to do configuration management, where we had the configurations of the devices and we track those and maybe we'd save those. Well, we're going to flip that on its head. And now we're going to have the configuration of the entire infrastructure version controlled. That's not just the configuration of the devices, but it is what the network is. We're going to have the configurations of the nodes themselves. We're going to have the configurations of the links, and we're going to have the configurations that pull together the whole infrastructure. And that's all going to be saved as code, so that now the code is the source of truth for our network. And if we do this right, and we're doing DevOps right, if we make a change to that code, then we're going to push that to the network. So the code drives the network changes. So there's a new process there. We're probably going to use some software development methodologies such as Agile. Included in that are continuous integration and continuous delivery or deployment. And that makes sense because continuous integration are changes to your software that do get tested and then they get pushed out, right? So we're constantly updating the production network in the end in small increments. Okay, but along with that, we're going to have pipelines to make sure that our changes are done safely, with less risk and probably improved quality. Okay, but then we're talking DevOps, right? So we have NJOPs, we do have new operating processes that are kind of like software engineering developers. Well, now the engineers and the operations, the new NJOPs, we're going to sprinkle on some improved programmability skills, such as understanding that data, because the code is the infrastructure now, right? So some kind of configuration, we have to save that. We're going to move those configurations around throughout our pipelines. So we're going to have to understand data serialization language, such as JSON and XML. And then we're also going to have to understand API requests, because that's how we're going to send the changes. Okay, so here is an example. I'd consider it one of the most important pieces of DevOps is the pipeline. And here we have on the left side, we have some kind of ITSM, some kind of ticketing system, some kind of system where we can request change. We could say, hey, look, I want this changed on the network. So it starts there. Doesn't have to start there. It could start at the next database. But anyway, let's just go with the ITSM, such as ServiceNow or something. And then on the far right, at the end of this pipeline, we have the production devices with configurations. And then in the middle of all this, we have all this goodness, all these checks that make sure that the production devices are exactly what we want them to be. So let's take an example. Let's say that, I don't know, let's say our organization changed our, like just a host name standard or something. So now we're encoding the site of the device, the role of the device, maybe the number of the device, and we're going to put that into the host name altogether. Well, we could make that request with a ticket in the ITSM that can kick off, hey, look, I want this configuration to a test source of truth, which is just some kind of database or version control anyway, some kind of database. An action can be kicked off to say, hey, look, I'm going to go ahead and test that. Does it pass a compliance check? Does it do what it says it's going to do? Is the encoding exactly what we want? Or maybe it's a more complicated configuration and it's a STIG configuration. Next, if that passes, we could, since the infrastructure is code now, we can spin up a test environment. And the test environment can have the device with the operating system it's going to have. We're going to push that config to it. Does it take it? We might even have some other tests that say, hey, look, does it do what it was supposed to do? And if that passes, then we're going to go ahead and send that to the next version control for the production devices. It could be the same one as the test, just another column or whatnot. It's a database. And maybe we kick off a new action. And that action is to go ahead and just make it happen. It passed everything else. We're going to push that to the production device. And now the production device has the intent that was put into the ITSM. But what I really want to focus on today are these now red arrows. These are the API calls. So in the past, we used the command line interface or the GUI interface as network engineers. Well, these arrows are the application programming interfaces. And these are made for machine-to-machine communication. So these are very important to the pipeline. So what are the API calls? Well, the machine-to-machine communication, there's two things that have to be the same. If one machine is talking to another, then they have to agree upon multiple things. So first off, the client to the server and the client have to agree on the methods. Like, hey, look okay, if the client makes a request and it's a get, then the server knows I'm going to return something. If the client says, okay, this is a post, the server has to know if I take a post, then I'm going to save some data. Patch would be to change it, replace it, that sort of thing. Right, so they have to agree upon the method if we're programming these. Second, they have to agree upon the payload, the serialization language of the data, so the configuration that's being sent, and they have to have an understanding of the data that's being sent. So the tags in XML, they have to agree upon the key value pairs within that payload. Otherwise, the applications can't understand it, right? So they have to agree upon that. And here we have some A to B or C to S client to server examples from the pipeline. ITSM, if it's sending that configuration, the source of truth has to be able to take it, know what to do with it. Maybe it's a post, save it, understand the data, and understand where to put it. On the other end, there's the client to the source of truth that's going to create an action that sends the configuration to the production devices, right? So they have to agree upon those things. So once again, once you have this pipeline going, because you are using DevOps and your engineering operation, it's DevOps now, there could be multiple API calls because you're sending that data to different processes to receive it and then run some kind of process as a check or whatnot on it, right? So there could be very many of those. Well, so the issue is if you have many APIs, you don't want them to be different. You want to standardize on your methods, which those are kind of standardized upon. But no matter what, if you have that configuration, you're going to want to standardize on the data that gets sent from the client to the server. Otherwise, every step in your pipeline, you're going to have filters and templates, and you're going to be adjusting things and munging it so that it works within the next process. So you could see from the many red arrows that you'd need to standardize the data, okay? And the way we do that is by using data models. So on the left-hand side of the screen here, you see there's a snippet from a Yang model, a Yang data model for the OpenConfig system. Okay, and we'll see that there's a leaf host name, and then this spells out that there's a type, and that's INET, it's a domain name. If I recursively looked into the OC INET, I'd see it's a string, and there's probably a regex that says, there's certain characters you can't have for the domain name. And then we have a leaf for domain name there, and actually it uses the same type because host names and domain names, it does the same thing. That's just the way they did it. But what I want you to really look at is here on the right-hand side, we have the OpenConfig system. This is actually the payload that gets sent. So this is a JSON encoded. And if a device or an API understands OpenConfig system, then it can process this. So this would be an example of sending a new host name and domain name from the ITSM all the way across the pipeline and to the device. So you see how standardized that is and easy it would be to program every step and just how clean and nice it would be. So of course, from the ITSM, we probably have another key and value for like device name, and there's probably going to be other stuff, but wherever we stuff those configurations in these API calls, these patches, puts, or posts, we're going to keep it just like that, okay? So that would be awesome, right? Devices take it, all our API, everything we program, our databases take it, but But it doesn't quite work that way, right? Because the reality is that many devices don't support, well, RESTconf and NetConf that can deliver these models, the JSON and the XML. And then if they do support it, not everything supports OpenConfig models. If you do support OpenConfig models, many devices don't fully implement them. And there's also things that aren't in OpenConfig models, such as like an enable secret password, right? So that's an issue for the models. So what do we do about that? How can we get to DevOps and pipelines and all this standardized data with devices with issues such as this, right? Well, here's a solution. Well, let's go ahead and take NSO and put it in between the devices. So we'll shim that in, and it receives the OpenConfig data, and it becomes the universal adapter to program any device. Okay, so with NSO, our pipeline carries the same payload, makes the same, uses the same methods. It's received on NSO, so now we can do all the checks, the testing, all the compliance, everything else. It gets programmed into the devices. Plus, you get other benefits of NSO. For instance, rollbacks. If there's an issue, we can roll back very easily on any device. We can have and if the transaction fails anywhere, and like we send the OpenConfig, NSO tries to program a device, then it'll go ahead and send a failure in the pipeline, and it won't program the device. Another huge benefit to this is we can create higher level services. For instance, if we want to create a layer 3 VPN between two routers, we could say, hey, look, here's the OpenConfig for device 1, here's the OpenConfig for device 2. We can hit NSO with those configurations, and now with that higher level service, it will go ahead and program the two devices. And what's great about that is if it's one service that receives the configurations for the two different devices and one of them fails, then it'll roll back both of them. It won't actually commit the whole thing. So it's transaction based. There's one transaction for the whole configuration system wide, if you'd like. Okay, so NSO, this is the way to make that happen. So let's take a look at that one. So OpenConfig, let's take a look at that, because this is the standardized data model we were talking about. This is the OpenConfig main page, and this is an illustration of the models. Go ahead and make that a little larger. And what we see here is all these different Yang models. There's top level models, and then there's other supporting models here, and they all fall under device, right? So you have interfaces where you can define the different interfaces that are a part of your device. You have network instances where you can define the different VRFs that might be on your device. And what's good about these models is they tie into each other. So authoritative for interfaces, the interfaces are listed here. If I create VRF ABC, now ABC's interfaces are actually defined in interfaces, and it links to them so that it's always right. Okay, so how did we take these the OpenConfig data models and apply them to the devices in NSO? Well, what we did was we created, so here's a package all on GitHub, NSO OC services. The source, we'll take a look at these models. What we did was we created a new container, okay, a container called OpenConfig. So it'll be MDD prefix OpenConfig. And we augmented the NSO's own device's device. So this will show up under every device. And then what we did was we went into, let me go to one of the top level models here, such as system. All these are supporting except for this one. And then what we did, once this works, wow. I hope you can hear me okay. This computer's acting funny. Let me go ahead and scroll down to the bottom of this. Okay, come on. Okay, so the different top level models, we went ahead and said, okay, why don't we augment that container that we added to the devices? And then, so each one is linked in. And what you get from that Okay, what we get, we'll take a look at a device. Let me look at this XE device here. Let's give that a few seconds to pull up. So usually we don't use the GUI, but for demo purposes, it's pretty good. So now under the device, so I went into devices, device. Here's a router, I called it XE1, just so I knew the operating system. I have MDD OpenConfig, and look, here's all the different OpenConfig modules or models. I'll take a look at system, and what we see is everything that would have been in the Yang, and we can program whatever we want into this OpenConfig model. Well, the key is, so now NSO is kind of like a big database, and it has all these fields where it can save different values in OpenConfig. But what we want to do is now take whatever values go into like OpenConfig system config, and we want to copy that into the device itself. So what we did there was we added service points. So let me go back, show you how that works. I'm clicking back here, so hopefully it'll really work. Ooh, the delay, wow. Okay, I'll just do that one more time. Okay, so let's back out just so, oop, not that one. Actually should have stayed in that. Go into OpenConfig. So let me just find a top level. So here's interfaces, OpenConfig interfaces. Under OpenConfig interfaces, yeah, just clicked on it. Do it again. We added a service point. So under interfaces, there's interfaces interface. Just gonna search for service point. Okay, so interfaces, there's a list of interfaces, and now we have a service point. So anytime data is added into that list, into an interface, this service point will kick off. And what happens next is that's identified. Back one more here. One more. Okay, here we go. By a Python process that's running. And these service points for, say, system here, it starts a callback, and it says, oh, we identified there was a change on this part of the model, so you go ahead and execute, and it makes a call to system callback. And system callback will run all the changes that were requested. Let's see, I got a few of these. Okay, so here's the callbacks. This thing will go ahead and run, and what will end up happening is we'll have identification for the different types of NEDs for the device. So it could be, once again, the universal adapter, and the idea is XE, XR, NX, and other devices as well, maybe perhaps even other vendors. This is an open source project, so that can happen. And then, this is called, and the device gets programmed. So let's go ahead and now that we see the service points entered, we see how all the programming is done. Let's go ahead and start a demo. All right, so what I have here is a CBIXE demo. Create a couple of playbooks, and what we're going to do first here is we're going to go ahead and configure the device using an API, and we're going to send it an OpenConfig payload. So here I'm using Ansible for this. It could use curl or Postman or anything, right? But this is the content. We're going to the device, and it's going to be MD OpenConfig, and we're going to add some DNS servers. Okay, so that's the content, and we're going to go ahead and send a patch. Got my right password and username there. It's going to be JSON. We're going to go ahead and pull that those configurations. So let me go ahead and get out of this. Here's the playbook, not that one. All right, let's go ahead and make this happen. So we're going to add 2 new DNS servers. So we went ahead and changed the YAML to JSON to send the data. and it ran and it sent it. Okay, and these actually were the lines that were implemented within the router itself, and we had an assertion and it passed. In fact, what we could do is watch that happen. So I've got a EEM script running on this so that whatever comes into the device is printed. Okay, so here we had 2 DNS servers. We sent them to the device. They were added to the device, and that was a patch, right? So I could, yeah, we'll just go ahead and move on here. Next thing I'm going to do is I'm going to modify. So I'm going to use a put API call, since the DNS servers in a router are actually a list, and say, hey, look it, I'm going to put with an 8881 or 8888 and the 208, 67, 222, 222, right? So I deleted the 8844 and I added this one. So this is a modify. So now I'm saying like this list, it's being redone. I'm using a put call, and what happened here? Well, that new server was added and the old one was removed, and we can see that down here. So these are actually, this is using a PyATS as a Ansible task, which is saying, hey, look at, what's the difference? It's grabbing the configuration before and after and seeing what's different. So that's a modify. So a put call to a list, like if it was an access list or routes or something, it'll just make things so. Otherwise, if you're using a patch, you're merging. So now let's use a delete call. So this will be a delete to NSO. And now we're removing 8888. Okay, so the method is delete. It's sending the OpenConfig structured data for 8888, and it's gone. Yep, no IP 8888. Okay, so that was removed from the device. Okay, so that was the demo. So now what we've done, let me go ahead and move back to the slides here, is we've made one API for your entire network. So if you think about why it's so easy to use the major cloud providers, they have one API to do everything within their clouds. And we just built that for all of our network devices, whether they support OpenConfig or not, whether they're different vendors, different operating systems. Now it's one API that can be programmed by NSO. So now the DevOps for networking turns networking into more of a data management and data operations. Okay, so here you'll see the link to the GitHub. This is an open source project, and the good news for everyone here is that you can use it. So what we have multiple customers that we're developing to now. So how many of the networks that are out there are going to use the same commands and devices that other customers are using, other folks are using? Well, because this is an open source project, this is like globally open, and the more people develop it and the more devices are added and the more features are added, then maybe there isn't anything. If you wanted to use it, it'll work fantastic. If you want to get involved, open an issue for perhaps a feature that you'd like, or if you run into a problem, then you can open an issue too. And if you want to add like a new device or something, feel free to clone it, make your changes, and add a pull request on GitHub. And that was model-driven DevOps with NSO.